Great. Everyone, thank you again for coming. And our next speaker is Kannupriya, who's come visiting Bay Area all the way from London. And she was telling me that she helps arrange the London Scala meetup. So while she's visiting the Bay Area, she was kind enough to agree to do a presentation tonight. So please welcome Kannupriya with Let's Teach LLMs to Write Great Scala. Thank you so much.
Thank you, everyone. Welcome, everyone. I'm absolutely thrilled to have you all here today as we embark on an exciting journey into the world of Gen AI. Today's session is all about exploring LLMs and how they can help us write structured, maintainable Scala code. Scala has so much potential in AI-driven development, and in this talk, we are going to uncover how it can be a game changer. A big shout out to Salar, Nathan, and thank you to Tubi for hosting this event at your office. Your support truly means the world. And now I can't wait to dive deep into this topic and spark some great conversations, which we can then continue after my talk. Thank you again for being here. Let's get started. A bit about myself. I have a decade of experience working with Scala and functional programming, focusing on backend development and big data applications. I have contributed to open source projects, mentored students in Google Summer of Code, and had the opportunity to speak at global conferences. Here's our roadmap for today's discussion. We'll start with a brief introduction to Gen AI and LLMs, explore how software engineering agents work, discuss why Scala is uniquely suited for AI-driven development, and introduce LLM4S, a Scala-first AI toolkit. By the end, I hope you'll walk away with a fresh perspective on AI in Scala. It's time to set the stage now. Gen AI, particularly LLMs, is reshaping industries by making complex problem solving more accessible to anyone and everyone. AI is advancing rapidly with LLMs at the heart of this revolution. These models are driving automation in coding, decision making, and natural language processing tasks. But can LLMs write production grade Scala code? In the world of AI development, Python has been the dominant language. Why? It's because Python is easy to use, has powerful AI libraries, and boasts a very vast ecosystem. However, Python is not without its shortcomings. Lack of type safety, runtime errors, and scalability issues being some of the biting ones. Enter Scala. With its strong type system and functional programming features, Scala can effectively address many of Python's limitations. In this session, we'll together explore why Scala deserves a more prominent role in AI development and how we can bridge the gap between the two. We'll delve into how LLMs actually work and whether they can produce reliable, maintainable code that meets industry standards. Time to dive deep into how LLMs actually work. LLMs, in very simple terms, can be described as word guesses. I mean, given a sentence, just try to guess what is the next word. For example, when I say once upon a, what's the next word? Oddly, they are so good at this storytelling, next word guessing, we can get them to write code one word at a time. So, once upon a time is a narrative that has been used in too many stories. Modern LLMs like OpenAI's GPT or Claude are trained on massive amounts of data and use deep learning techniques to generate human-like responses. They can be used in various ways. For example, zero-shot prompting, which is actually the ability to perform tasks without prior training on specific examples. Second way LLMs can be used is tool calling, which actually means allowing LLMs to interact with external APIs and databases, which is something we do a lot as backend developers. Third way LLMs can be used is called self-feedback, which can be understood as react looks, which means evaluate tool output and iterate to improve results. This concept is the core of agentic programming. We can enable LLMs to solve all kinds of problems like generating code, debugging errors, and optimizing workflows. But how do they perform this in a strongly typed language like Scala? Let's explore further. AI-powered development has come a long way. Today, LLMs can assist in writing software at different levels of complexity. Let's break it down quickly. First, there's the simplest level. If I ask an LLM to write me a function that adds two numbers, it can do that easily. It generates a basic function, understanding syntax and logic, but without much context. The next level is Copilot. We all are now familiar with tools like GitHub Copilot. These works like supercharged IDE autocomplete features who predict and suggest the next few lines based on local context. They make coding more efficient, reducing the boilerplate and catching patterns as we write. They are the ones that, when we add as plugins in IntelliJ, suggest the code pop-ups like insert me based on what problem we are trying to solve in the IDE. Now, third level is called agents. This is when things get really interesting. Unlike Copilot, agents don't just predict the next line of code. They actively work on solving the problems. You give them high-level instructions and they analyze the entire code base, interact with APIs, generate multiple functions, and even debug their own output. They don't just assist, they take actual ownership of the solution. If you go and see the logs of an agent at work, you can see how it actively records everything it did with great logging ability to track back if required. So, what's the key difference? What's the takeaway here? Co-pilots work on a local level. They help with the context of the function or file you are working on. Agents, on the other hand, operate at global level. They can understand and modify an entire code base, making them powerful tools for AI-driven software development. Now, I won't cover every single capability of LLMs today, but our focus will be on how they can be used for writing structured, maintainable software. Time to dive deeper. SWE Bench. It's a way to benchmark the performance of software development agents. It was actually specifically made for Python-related tasks found in GitHub issues. It provides a standardized framework for evaluating how well these agents handle real-world issues that developers face time to time. The set of issues used in SWE Bench are focused on Python code problems, and that's why the evaluations are limited to this domain. Agents such as Aider, OpenHands, and Agentless are some of the top contenders that have been tested using SWE Bench. Though SWE Bench is useful, it's worth remembering that it only looks at a subset of possible issues. By this, I mean that these agents might perform differently in other scenarios or on a broader problem set. We know that these agents don't generalize very well, at least until now. They can solve issues, but they are far from being perfect. So, how do we evaluate them? As you can see on the leaderboard here, the performance of these agents is compared based on how many test issues they are able to successfully solve. They take a GitHub issue and the code base and attempt to generate the right software change. Biggest wins so far are when the LLM gets better. So the LLM keeps getting better, but the tool still have a long way to go. Claude 3.7 has just been released yesterday and is claiming further improvements, but this table only gets updated every week. Now, how do we make agents build software? A key innovation in AI-powered development is SWE agent architecture. Think of this as an AI agent that writes, tests, and refines its own code. How does it work? The agent operates in a containerized workspace where it has access to tools and test environments. It iterates just like we human developers do. Take instructions, generates code, run tests, observe the results, and then repeats all of this. The agent's self reflection mechanism ensures continuous improvements keep happening. Errors are fixed, tests are refined, and code quality is enhanced. Getting agents to generate Scala will help the agent do its work by giving more timely feedback. For example, type errors. This approach can be described in simple words as fail fast, fail early, speed up the development life cycle. We all know that Scala is a fantastic language for building robust and scalable software. That's exactly why we all are here today. Whether you are using Scala for backend development, big data, or distributed systems, you have experienced its power firsthand. But here's the challenge. While Scala excels in many areas, AI and ML tooling is overwhelmingly dominated by Python. Why is that? More importantly, can we change that? Let's dive into why Scala deserves a place in AI development, how we can bridge the gap with modern LLM techniques, and how projects like LLM 4S are paving the way for structured, type-safe AI solutions in Scala. Let's explore this together and see why Scala should be at the forefront of AI innovation. Now, I have said so many times, Python is dominant in AI, but Scala offers unique advantages for AI-driven development. Let me break it down for you. Building AI tools in Scala is better. Getting LLMs to write Scala, it can build better code even faster. Type safety, LLMs often generate incorrect or inconsistent outputs. Scala's strong type system helps enforce constraints, reducing runtime errors. Next one is reliability and maintainability. Functional programming features like immutability and pattern matching help create robust, scalable application. Third one being strong collections library. Now we have all used it very well. So I'll skip that and move on to the next one, expressive code. Scala's concise syntax allows for expressive AI logic without sacrificing performance. And the last one being interoperability. Scala can integrate with existing AI tools while providing more structure and safety than Python. And like I discussed, fail fast, give good feedback. This is what a typed language gives you. This is actually a hack in Python. adding Pydantic and MyPy to try and enforce things built into the language already. We'll see how these features help in real-world AI-driven applications. Introducing LLM4S, a new Scala-first AI development toolkit. This project aims to bring structured type-safe AI development to Scala. Here's what it will offer: structured AI workflows, which will ensure AI-driven applications follow predictable, maintainable patterns. Next, tool calling and API interactions. They will be seamlessly integrated with external tools, APIs, and databases. Third one being multi-step workflows, which will support iterative development and feedback loops similar to Python's LangChain. Fourth, agentic workflow framework. Fifth, Scala native AI development, leveraging the Scala strength to improve reliability in AI workflows, both in tooling and in code generation. LLM4S is still evolving, but it promises to make AI development in Scala more accessible and efficient in multiple ways. To wrap up, let's recap what all we have covered so far. LLMs are powerful, but current AI tooling is heavily Python-centric. Second takeaway, Scala provides better type safety, reliability, and maintainability for AI development. Building AI and getting AI to build software can be done better. The SWE agent architecture being the third one, which enables AI-driven software engineering with feedback loops. And last, LLM4S, which is a promising Scala-first AI toolkit that brings structure to AI development. Next steps are to get involved. Whether you are a Scala developer, AI enthusiast, or open source contributor, we encourage you to explore LLM4S and help shape the future of AI development in Scala. As we close, I encourage you to explore how Scala can enhance AI development. Think about what a type-safe AI ecosystem looks like and how we can push the boundaries of AI in functional programming. If you are interested in contributing, check out the LLM4S on GitHub, explore open issues, and join us in building a type-safe AI-powered Scala ecosystem. We welcome collaborations from AI engineers, Scala developers, and all open source enthusiasts alike. If you enjoyed this talk, please consider starting the project on GitHub. Before we wrap up, I would like to take a moment to introduce the incredible maintainers of LLM4S. Rory Graves, a Scala expert with over 30 years of experience, has made significant contributions to Scala compiler optimizations and AI-driven research. A huge thank you to Rory for being an amazing co-maintainer on this project, for his invaluable contributions to the creation of LLM4S, and for giving me the opportunity to work alongside him in maintaining it. We would be delighted to connect on LinkedIn to discuss this project further, looking forward to collaborating with you. If you are interested in exploring this or discussing topics related to open source, Scala, and AI, we would love to have you join us at the upcoming London Open Source Hack Night tomorrow at 10 a.m. PST, both online and in person for those in London. You can find all the details in my LinkedIn post for this talk. And this image is from the Scala Open Source Hack Night in London, where we actually brainstormed and discussed this project. To wrap up, here are some resources to further explore the fascinating world of LLMs, intelligent development, and agentic programming. These links provide insights into cutting-edge AI advancements, evaluation frameworks, and open source projects that push the boundaries of Gen AI. I encourage you to check them out and continue your learning journey beyond today's session. Thanks again for being here, and thank you for being a fantastic audience. Feel free to reach out, ask questions, and connect on LinkedIn. Let's continue the conversation and work together to shape the future of AI and Scala. Thank you, everyone.
Any questions? Okay, great. Thank you so much for doing the talk tonight. It was really appreciated coming from London. Hope you're enjoying San Francisco.